So this lecture covers the concept of the backtracking for the problem, that is n queens problem. So coming to the n queens problem, that is using the backtracking, the problem is to place n queens on n by n chessboard so that no two queens are under attack by being in the same row or in the same column or in the same diagonal. Given the n chess queens, you need to place them in the chessboard of the size that is n by n so that no two queens are attack or eliminate each other. And a queen can only be under attack if another queen is either on the same row, the same column, and as well as the same diagonal. So what does this means? So consider the value of your the n to be equal to 4. That is n equal to 4. There are 4 queens which are present. That is queen 1, queen 2, queen 3, and similarly queen 4. We are not considering any other items within your chessboard. Only the queen is being present. So here there are n equal to 4. That is 4 queens, and it is a n by n chessboard. So it is n by n chessboard. And when you consider the n by n chessboard, that is will be having 4 by 4 cells. And when you place the queen 1 in this scenario, that is in the first row, first column, then we cannot place the queen 2. That is, we cannot place the queen 2 either in queen 2 cannot be placed in this position, and similarly we cannot place in this cell. In the same fashion, queen 2 cannot be placed due to the reason like the next queen cannot be placed either in the same row or in the same column or in the same diagonal. So queen 2 cannot be placed here, and queen 2 can be placed, but even if you place queen 2 here, this is not the feasible solution. I already have discussed the same thing in your previous video. Similarly, if you place queen 2 here also, this is not the viable solution, because when you place queen 2 in this that is second row and similarly third column, we cannot place queen 3 here, we cannot place queen 3 here, and similarly queen 3 cannot be placed here, and queen 3 cannot be placed because these two will be under attack, and similarly this will be under attack, this comes under attack, and similarly this also comes under the attack. And that is the purpose where we cannot place queen 2 in this cell. So when you place queen 2 in this cell also, we do not have the possible solution. So what is the possible? We cannot have the solution. What is the solution? That is, when you consider queen 2 is being placed in your second row and the fourth column, queen 3 cannot be placed here because these two queens will be under attack. And of course, you can place queen 3 here. And when you consider about the queen 3 which can be placed here, there is no placement for your queen 4. That will be discussed. So when you here queen 3 is being placed here, assume, then in such cases queen 4 cannot be placed here, queen 4 cannot be placed here, queen 4 cannot be placed here because these two queens will be under attack. Queen 4 cannot be placed because these two queens will be under attack. Queen 4 cannot be placed because queen 3 comes under attack with the queen 4. And q4 cannot be placed because q2 and q4 comes under attack. That is the purpose when you take q1 at 1, 1, that is first cell, first row and similarly first column, you cannot get the solution and backtrack. The concept of the backtrack is being applied. So when you apply the concept of the backtrack, find the other paths which are being available. You have started the queen 1 to place at the first row, first cell, first row, first column. When you place queen 1 in the first row, first column, then there is no solution. That is, here we have seen when you place queen 1 in this position, then we do not have the solution. In the same fashion, as we have learned from the previous video, we are starting from placing the queen 1 in the first row, first column, and similarly queen 1 in the second first row, second column, and so on. And similarly queen 1 can be placed in the first row, third column. Alternatively, you should also find the possible solutions where the queen is being placed from in the first row, the fourth column. So when you place queen 1, when you place queen 1 in this position, then it is not the solution. This cannot lead to the solution. So what you are doing now, you are backtracking and checking whether queen 1 can be placed in the first row, second column. So we shall find out. So when you place queen 1 in first row, second column, then the queen 1 is being placed successfully. As of now, the condition is being satisfied because there is only one queen that we are placing. And queen 2, so queen 2 cannot be placed here. Queen 2 cannot be placed here because it comes under attack with the queen 1. Similarly, queen 2 cannot be placed here because these two queens will be under attack. So queen 2 cannot be placed here because these two queens comes under attack, and q2 cannot be placed here because these two queens will be under attack because it comes under attack with the queen 1. So what is the next kind of the arrangement that we can do? We can place q2 here. There no two queens will be under attack because we have placed q1 in the first row, the second column, and queen 2 is being placed in the second row, the fourth column. So there are no clashes because these two queens are not in the same row in the chessboard, not in the same column within the chessboard, same chessboard, and it is not in the diagonal part. Now take the next kind of the q. So here if you take q3 and place here, that is if you place here q3, of course this is one of the solution, because you can also take this as one of the, because no two queens will come under attack. So where the queen 3 can be placed, so queen 3 can be placed in this position. And how about the queen 4? So we cannot place queen 4 in this cell because the same queen, it comes under attack with the queen 1. So we cannot place q4 here because these two queens will comes under attack. q4 cannot be placed because it comes under attack with the q2. Similarly, q4 cannot be placed here because these two queens will be under attack. q4 cannot be placed because the same row as well as the same diagonal. And similarly, when I place this kind of the 2 4 1, and if I place q3, I mean q4 in this cell, then no two queens are under attack because it does not come under attack with the queen 1, queen 2, and similarly queen 3. So queen 4 can be placed, and you don't have to go further the next levels. So one of the possible solution is, that is 2, 4, 1, 3. What does this stands? You are placing the first queen, first row, the second column. First row, second column. And similarly, you can place the second queen in the second row, fourth column. And you can place the third queen in the third row, first column. And you can place the fourth queen in the fourth row, the third column. So this is one of the solution. And by using the concept of the backtracking, we can also find other possible solutions which may lead to the final solution. So according to this kind of the problem, that is, if you take the 4 queens problem, so within your 4 queens problem, there are 2 solutions. The 2 solutions are 2, 4, 1, 3, the same thing that we have discussed so far. And the other solution is, you can take 3 comma 1 comma 4 comma 2, the arrangement of the first queen, that is first row you are placing. Like take for example here, if you consider the 4 by 4 chessboard, and similarly this is a 4 by 4 chessboard, and you are placing the queen 1 in the third cell and q2 in the first cell of your the second row, q3 in the third row of the fourth cell, and q2 is being placed in this cell. So when you place these cells in the respective arrangement, we can obtain the solution. How can we obtain this one? How to identify all possible solutions? That is what the concept of the backtracking is been involved. So what we have done, that is we are starting from the root and find whether I can place q1 in 1, q1 in 2, q1 in 3, or q1 in 4. If you take q1 in 1 and find whether I can place q2 in 1, and similarly this process goes on. If at any case, if it not leads to the solution, backtrack and find the other possible paths until you reach to the respective end. That is what the concept of the 4 queens problem is being involved. So the same thing, that is 4 queens problem can solve it by using the backtracking technique. So given the example, like we need to take the 4 queens problem and find all possible solutions. So consider the 4 by 4 chessboard, because n value is equal to 4, n by n, that is 4 by 4 chessboard, and there are 4 queens. The objective is to place 4 queens on the 4 by 4 chessboard, such that no 2 queens should be placed in the same row or the same column or the same diagonal. So here, according to this case, I've explained the same thing. You're placing the queen 1 in the first row, first cell, and the next queen, that is you can place the queen 2 in the second row, third cell. And similarly, when you place the queen 3, then there is no solution that can be found to place the queen 4. And that is the purpose where it is not the feasible solution. Similarly, backtrack. And by applying the backtrack, you are moving the queen 2 to the 4th position. So when you are moving to the 4th position, queen 3 can be placed in the third row, first cell. No 2 queens are under attack. And similarly, queen 4 can be placed in the 4th row, third cell. So this is one of the solution, that is 2, 4, 1, and 3, and similarly 3. And this is how we have obtained one of the solution. But to consider about how many number of such solutions can be found, that is this is where we can identify about the state space tree diagram. The state space tree diagram indicates that is x1 equal to 1, that is queen 1 is placed in the first row or first column, and alternatively, that is you can place the queen 1. Here it is been represented as, that is x1. So x1 is being placed in your first row, first column, or take the first, choose the path. That is when you take a queen 1, find all possible paths which are being available. This kind of the tree diagram indicates the 4 queens solution space with nodes numbered in the depth first search. That is x1 equal, you can place queen 1 in the first row, first column, and queen 1 can be placed in the first row, second column. Queen 1 can be placed in the first row, third column, and queen 1 can be placed in first row, fourth column. When you take x1 equal to 1, then we have the other paths, that is queen 2, queen 3, and similarly queen 4. And when you take queen 2, then the other paths which are being available are q3 and similarly q4. And this process continues. This is your entire state space tree diagram. The entire state space tree diagram that can be generated for the 4 queens problem. That is, take a q1 and the other queens that are being present are q2, q3, q4, the other paths where you can place x2. That is x2, that is queen 2, can be placed in the second row, second column, second row, third column, and queen 2 can be placed in second row, fourth column, because first is already been occupied by the queen 1. In the same fashion, when you place queen 1 in the first row, second column, then queen 2 can be placed in. This is your x2, this is your queen 3, and this is your queen 4. I mean the fourth queen. So or if you take the queen 1, so queen 1 which can be placed in your first row second column, then I can place queen 2 in either the second row first column or the third column or the fourth column. In this fashion, you'll be filling out all possible paths which are been available. So total you can observe that is 65. There are something around 65 nodes which are being present according to this kind of the diagram. So this is not actually the concept of the backtracking. This is your state space tree diagram. What are the possible paths which are been available to solve the problem of the 4 queens. So this will be the final solution which can be obtained using the backtracking concept. What does this concept says? That is, in all the introduction related to the backtracking, I've explained in such a way that when you find a path which leads to the solution, move to the next level. If not, that is, if either the constraint is not being satisfied or the condition is not being satisfied, then backtrack. So this is the the solution for the 4 queens state space tree diagram using the backtracking concept. What does this kind of the diagram says? That is, you are placing x1 equal to 1. That is within the case of the n by n chessboard. That is, take the first one. That is x1 equal to 1. You are placing queen 1 in the first row, the first column. Then, can I place, if I place q2 here, then these 2 queens will be under attack. That is queen 1 and similarly queen 2 comes under attack. And that is the purpose where the backtrack function is being implemented. Or we can also say the bounding function. So here the backtracking indicates when you place queen 2 in the second row, second column, we cannot get the solution. When we cannot get the solution, backtrack, move to the previous level and find what are the various paths which are been available. So the same thing you can observe the previous part. That is, we are starting from the x1 equal to 1 and x2, that is this, we are placing the second queen in the second column. We do not lead to the solution. Backtrack and find the other paths. The same thing here you can observe. That is, when you place the second queen in the second row, third column. So when you place the second queen in the second row, the third column, we may get the solution. So we are moving to this kind of the next level. And x3. So x3 equal to, how about the case of the x3? If you consider the entire state space tree diagram, that is, you can take either 2 here in this case, or you can take the 4 here in this case. That is, you can take 2 or you can take 4. What does this mean? The third queen, this is your p2, sorry, and the third queen can be placed either in the third row second column or third row fourth column. So when you place the queen 3 in the third row second column, and you place the queen 3 in third row second column, these 2 queens comes under attack. That is what the backtracking concept is being involved. Backtrack, that is, move to the previous level and find the other path. And when you reach to this kind of the path, what does this mean? That is, you are placing the queen 3 in third row fourth column. Third row fourth column. Then these 2 queens comes under attack. And that is the purpose the backtracking concept is being involved. When the backtracking or the bounding function is being applied, then move backwards to the previous level and find the other path. So the other path, that is, you are choosing x2 to equal to 4. What does this mean? That is, you are placing this kind of the queen in the second row fourth column. So second row, the fourth column. When you place the queen 2 in the second row, the fourth column, yes, it may lead to the solution, maybe. Then what is the other paths that can be taken? That is, it can be either 2 or it can be either 3. That is, the queen 3 can be placed in the third row, second column. Here, as of now, no queens are under attack. And how about the case of the queen 4? That is, this is 1, 4, 2, and the remaining is 3. That is, you need to compulsorily place queen 4 in the third cell of the fourth row. That is, if you place this queen 4 in the third row, then these two queens will be under attack. That is what the backtracking concept is involved. So backtrack and place the queen 3. Place the queen 3 in 3. What does this 3 indicates? Third row and third column. If you place a queen 3 in third column and third row, these two queens will be under attack. So the backtracking, because it is a criterion function, the condition is not being satisfied. So you are applying the backtrack. When you apply the backtrack, move backwards because this is not the possible solution, and choose the next path. The next path is you are choosing, you are placing queen 1. You are placing queen 1 in first row, the second column. So you are placing queen 1 in the first row and as well as the second column. So when you place this one, as of now, no queens are under attack. When you take x1 equal to 2, what about the other paths? That it can be either 1 or 3 and similarly 4, where x2 value equal to 1, 3, 4. What does this mean? That is queen 3. Queen 3 can be, queen 2. Queen 2 can be placed in second row, first column. If I place queen 2 in the second row and the first column, then these two queens will be under attack. That is how the backtracking concept, that is, move backwards to the previous one level and find whether queen 2 can be placed in the second row, the third column. So when you place queen 2 in the second row and the third column, then these two queens will be under attack. And that is how the backtrack is being implemented. Move backwards and find the other path. So the other path is you need to place x2 equal to 4. That is queen 2 in the second row, the fourth column. Queen 2 is being placed here. So here, if you place queen 2 in the second row, the fourth column, it does not come under attack with the queen 1. As of now, there is no problems. So take the next level. So the next level is nothing but you are placing the queen 3 in the first cell. When you place queen 3 in the first cell, no two queens are under attack. It does not come under attack with the queen 2, or it does not attack with the queen 1, and so on. And how about the next case? That is queen 4 has to be compulsorily placed in 3. So 1, 2, 3. So queen 4 has to be compulsorily placed because that is the only option that is been available. If you look at the state space tree diagram, that is, if you take 2 and similarly the next one is of the 4 and the next one is of 2, 4, and then you have, if you took 1, then definitely it will be equal to 3 only. The same thing. That is, when you place queen 4 in fourth row, the third column, then it is the solution, one of the solution. That is, so we have indicated 2, 4, 1, 3. In such case, that is, this has been led to the solution. That is the final solution because we got the solution. And there are also another paths which are available. What are the other paths? Here we have taken x1 equal to 1, and then the backtracking concept has been implemented. And similarly, when you take x1 equal to 2, then the we got the solution, that is 2, 4, 1, 3. In the same fashion, when you place x1 equal to 3, what does this mean? That is, when you place x1 is equal to 3, that is in this entire state space tree diagram. When you take x1 equal to 3, find whether if you place queen 2 in the second row, the first column, whether it leads to the solution. If it leads to the solution, move to the next level. If it does not lead to the solution, then backtrack and then find the other paths. So in such cases, the other solution that can be obtained is 3, 1, 4, 2. So there are two solutions. The first one, that is 2, 4, 1, 3, and the next one is 3, 1, 4, 2. This is what we can say about the concept of the backtracking. So backtracking concept is being implemented using this kind of the concept, that is 4 queens problem. And in the next part, I will cover about the concept of that is n queens problem. So if you consider about the n queens problem, within the case of the n queens, we can say like for a given n value, that is n equal to something like of 4, and we have taken this kind of the solution. And when you take the value of the n to be equal to 5 or n need to be equal to 6, then how we can write the algorithm for the case of the n queens problem. So within the case of the n queens problem, that is algorithm, you need to take n queens of k comma n, and for I equal to 1 to n do, you are checking whether if place of k comma I, if it is suited, then in such cases place I into x of k, and you'll be checking if k is equal to n, then write x of 1 to n, the path that you have taken into the solution. Else you are recursively calling, that is n queens of k plus 1 comma n, and this is how we can write the algorithm related to your n queens. That is if you are placing certain kind of the queen in the respective place, and if it is the feasible solution, then you are writing that kind of the path. If it is not, then backtrack by moving to the next level. That is q1 can be placed in your second cell, first row, second cell, and so on. Similarly, when you consider about the n queens algorithm, within the case of the n queens algorithm, you are starting from I to n. You are starting from 1 to the how many number of queens that are being present, and you are identifying. So you are identifying by placing this kind of the value of the k in the respective position of the I, whether it leads to the solution or not. If it does not lead to the solution, then backtrack. That is, move backwards to one level and find what are the various other paths which are been available. If there are various paths which are been available, then in such cases, choose a particular path and then go to the next level, find whether it leads to the solution or not. If it does not lead to the solution, apply the backtrack and then move to the one level up. And if you are exhausted all the paths on that particular level, move to one level up and then find what are the various paths which are being available. Out of these paths, find which leads to the solution. If it does not lead to the solution, choose the other path, and so on. This process continues until you reach to the optimal solution. So the advantage of using the backtracking concept is you can find all possible solutions. You can find all possible solutions. Unlike within the concept of the dynamic programming, you cannot get the all possible solutions. You can get the solution, but not of the all possible solutions. But using the concept of the backtracking and with the concept of the state space tree diagram, you can find all possible paths using the backtracking concept.